This lecture is for Chapter 7, Repeated Measures Designs for PSY 222, Research Methods in the Psychological Sciences. In the chapter before this, in Chapter 6, we had talked about between groups designs where you are often testing the difference in impact between levels of an independent variable, or comparing naturally occurring groups on a dependent variable of interest. Now we want to look at in my mind, a more complex design, and often a type of design that students can find confusing, not so much conceptually, but in terms of the data analysis that's involved. Now, in Shaughnessy, we're looking at it from a design point of view. You will get to, when we're doing the SPSS work in Pallant, there will be a whole section on repeated measures designs where you will look at the kind of elements, the complications that are involved in doing the statistical tests for looking at repeated measures designs. So first we need to get some definitions out of the way and get some kind of understanding, just in a general sense, of what do we mean by a repeated measures design. So first off, let's revisit what we learned about independent groups designs. And the independent part of that means you're randomly assigning, or people come in with a characteristic that naturally assigns them to separate groups. So you have different groups of people representing different conditions in an experiment or a study. So you have a separate group of people serves as the control group in your experimental design. Or you have people in naturally occurring groups, say you're comparing males with females, for example, or you're comparing freshmen versus sophomores versus juniors versus seniors, for example. Those would be considered, naturally occurring independent groups as well. In repeated measures designs, instead of having, as you would in an independent groups experiment, where you would have a group of people assigned to a control group, in a repeated measures design, every participant experiences every condition of the experiment. So you're repeatedly being assessed, either in an experimental condition or a control group condition, and those orders are often balanced. So all of the people who are sampled, as in this image, are going to get the first treatment or the first condition of the independent variable. They will all get the second condition of the independent variable, and they'll all get the third condition of the independent variable. So why it's called repeated measures, at each of these treatment phases, or in each condition of the independent variable, you will take a dependent variable measurement. So it's within subjects, so all the participants are repeatedly measured. And essentially what you're doing is using the participants as their own controls. So for example, treatment 1 might be the independent variable is applied. So say it's a treatment condition. Whereas treatment condition 2 might be a control condition where the treatment is removed. Treatment 3, the independent variable may be applied. Now, for some people, you might vary the order, but just at this point, what you're doing is saying, I'm going to compare all of my participants, their performance under the treatment versus their performance under the control condition, and that allows me to use the participant's own performance as its own control. So each individual participates in every condition of the experiment, and the dependent measure, whatever measure you're using, is going to be taken with each condition. So for example, I had some seniors who were wanting to test the impact of the use of a weighted blanket, And we decided that the approach that would be the most useful for them is a repeated measures design. Um, and so they had participants who they would arrive at the laboratory, they would complete their initial intake measures, then they would lay down in a chair, recliner chair, and they would, depending on their start position, because some of the participants started with the weighted blanket first, other participants started with just a sheet first. But regardless, all participants had measurements taken of the dependent variables, both with the blanket and without the blanket. So they did start point measures, then they did with the blanket, they did without the blanket. Some of the participants started with the sheet, then did the blanket. Other participants started with the blanket, then did the sheet. So what you do is at 3 points in time, the participants filled out a perceived anxiety and stress questionnaire. They had their heart rate taken. They had their heart rate variability measured. Then you apply the treatment, so either a sheet or a blanket. Then they measured perceived stress and anxiety, heart rate, and heart rate variability again. Then they apply the second condition, either a sheet or a blanket. And then finally they measured one more time. So statistically what we were trying to do was then look at comparing when they had the blanket on versus when they had the blanket off. And the main advantage to doing repeated measures is that the participants themselves come in with all kinds of individual differences. By having participants serve as their own controls, it's a particularly powerful technique if you can show that there are in fact meaningful differences. Another name for this type of design is a within subjects design. And the word within suggests you're using the same group of people, but you're measuring them under different conditions. So it's within the subject group. And that's in contrast to between groups designs, which is another word that we use to describe independent groups designs, where you're comparing different groups of subjects in terms of their performance on the dependent variables of interest. Now, what are some advantages, or why might you choose a repeated measures design? Well, if you have a situation where you want to be able to use a smaller number of participants, maybe you have limited access to participants, maybe the issues that you want to study are ones that are going to make recruiting for participants difficult, or you have a limited period of time in which to complete your data collection round. And that's what happened with my senior research group. We only had so much time to do data collection, so we wanted to maximize our use of a small sample. So if you want to conduct an experiment where only a few people are available, or you have other kinds of limitations on subject time, this may be an advantageous design. Second, repeated measures designs are time efficient because you are conserving the number of experimental sessions that you have to conduct. You're not having to recruit a separate group of 20 people for your independent or your experimental group and another 20 people for your control group. Instead, you can just recruit 20 people, and they're exposed to both conditions, so you're actually cutting your time in half in terms of data collection. From a methodological standpoint, one of the advantages of repeated measures is it does increase the sensitivity of the experiment. And what that phrase means is it increases your ability to detect patterns, to detect effects of your independent variable, because you're able to avoid some of the pitfalls of between subjects where you have more error associated with individual differences. Since your own participants are serving as their own control, then you're lessening the impact that those individual differences would have. Another advantage to repeated measures is that you can look at the impact of time. Essentially time, the passage of time, and things like practice effects or fatigue effects can be detected and then understood with a repeated measures design. And that helps you as a researcher to be able to say, as it did with the weighted blanket study, well, what if just sitting for 30 minutes quietly, regardless of what you're covered with, reduces your stress? That was a question that we had to kind of think through when we were thinking about that study. So we needed to, even before we could attack that in a separate kind of way, we needed to understand the impact of time and make some comparisons in advance. So the design does allow you to study participants over time. Now let's dig into a little bit more the issue of sensitivity, and by what we mean by that is the ability to detect the impact of an independent variable, even if the impact is somewhat small. With a within subjects design or repeated measures design, you do have greater sensitivity, as I was saying before, since you're using the same participants in all conditions of the experiment. Any naturally occurring individual differences, like in the weighted blanket condition, some people have experience using weighted blankets already. Some people don't. Some people get really hot when they're under a blanket. Some people are cold all the time. Some people have a baseline difficulty relaxing. Some people are just chill. Those are individual differences. By using a repeated measures design and having all participants, regardless of all those messy differences, having them in every condition of the experiment, it spreads out those differences. Now those differences represent error. Because those differences could have an effect, let's say you're someone who uses a weighted blanket, it's effective for you, you believe already it's going to make you more calm. And in fact, maybe your heart rate does go down. Maybe your heart rate variability does go up, all of which are signs of stress reduction. That fact that you believe it's going to be effective may, in fact, affect how you respond. Other people will not have that pre-existing mindset, so their responses wouldn't. The fact that you have some people with expectations, some people without, and they're all experiencing all conditions, you've eliminated or at least moderated a source of error. And that's what your authors mean by less error variation. It's always, the uniquenesses that our participants walk into our laboratories with, that we always kind of just spend a lot of time as researchers going, how do I control for this error? Well, the repeated measures design is one of the key ways of doing that. Now, how do you do that in an independent samples design? You randomly assign people to conditions. There's still a possibility that even with random assignment, you have some quirky weirdnesses of those individual differences that might impact your findings. So the added sensitivity of the repeated measures design means that you have an extra layer of reduction of that kind of error because everybody is in every condition, regardless of who they are. So another way of putting that is that by having the same people, all participants in every condition, it's going to mitigate the impact, at least potentially, of those individual differences, and it eliminates the need for that kind of for matching. It eliminates the need for even random assignment to groups. Excuse me. What this relies on is that when we're thinking about participants and we're thinking about them as individuals, you have to remember that across people, there are more sources of difference. There are more possibilities of difference. And that's what your authors mean by variation between people. So for example, in terms of their baseline perceived anxiety, the participants in the weighted blanket study were all across the board. College students have a tendency in general to have higher perceived anxiety and stress scores, but there were some people who were super chill and some people who had just high baseline anxiety, and all, very highs and lows. If you took any two people, it's likely that their scores would be quite divergent. So within that group of people, you have lots of individual differences. And that's what your authors mean by there's usually more variation between people. Now, the within people part, what that means is if I gave participants repeatedly the same test of perceived stress, leave all the variations of what blanket we're applying, put that aside. If I just gave them that measure 3 times, they're going to give me the same responses, within a point or two. So that means there's less variability within each person than there would be when you're comparing them across a particular measure. So when we take advantage of that, what we're doing is saying we're eliminating these between people sources of error, or at least mitigating them. Still within your sample as a whole, you're going to have individual differences. But the fact that you're able to put everybody in every condition, the statistic that you actually do, the math of it, takes that into consideration and gives you a more sensitive test for detecting changes. Given that you have less error variation, what that means is you have the capacity then to detect small differences. Without going into the math of these, because this is not a math-based stats class, when we calculate between groups differences, as we discussed in the last chapter, one of the factors that's in those formulas is error associated with between groups differences that aren't due to the independent variable. In a repeated measures design, you have less concern about that because you aren't comparing different groups of people. So you don't have to factor in this big chunk of the formula that's based on the differences inherent in individuals who are randomly assigned to separate groups. Having that source of error, you have to set the bar higher for saying that you have a significant difference between groups. Since you don't have that with a repeated measures design, you can detect you can declare a smaller difference significant when you wouldn't be able to in a between subjects design. Now, I mentioned earlier with repeated measures studies, one of the things that we have to think about is something called practice effects. Repeated measures designs, they can't be, as your authors put it, confounded by individual difference variables. So you're controlling for that. What happens though, you have to really think about what happens just because of the passage of time. And we call those practice effects because one thing that you can study with repeated measures design is you can give people a test under certain conditions and their performance may in fact improve under condition A, say, and then under condition B, which is different conditions, maybe their performance still improves. It might be due to the change in condition, it might not. It may just be because they've done the task more than once. So one of the challenges with repeated measures is being able to determine how much of the change that you're seeing is due to simple practice effects and how much is change due to the manipulation of your independent variable. So performance in repeated measures designs may change simply because you're testing them more than once. And that's something that in a repeated measures design you have to be careful of because it will threaten, as your authors put it, your internal validity. Now remember that internal validity means the degree to which you can isolate your independent variable, so how much experimental control you've exerted to eliminate all other possible causal explanations for any pattern that you detect in the data. Ideally, what you want is to be able to completely isolate that independent variable, and all the other extraneous variables you've controlled for. In a repeated measures design, you have to find a way to control for those practice effects. So, for example, in the weighted blanket study, we did create a between subjects variable. And what we did, everybody still explored, participated in every condition. We randomly assigned them, though, to different orders of repeated measures. So some people started with a sheet, some people started with the weighted blanket, and then they reversed. So by doing that, what we were able to was control for practice effects. We had to make a comparison of the two groups to make sure that there weren't between groups differences that were due to order, and what we were able to determine at the end of the day was the two groups didn't differ. So then we were able to collapse across the two groups and run our repeated measures analyses. So that's something that you have to do in order to determine whether or not practice effects have an impact on your dependent variables to such a degree that you can't make an inference about the impact of your independent variable on your dependent measures of interest. So with repeated measures designs, you have what are called complete and incomplete repeated measures designs, and we're going to explore both of those in this chapter. And in different ways, they're labeled this way because they deal with practice effects differently, and give you therefore different levels of ability to draw those causal conclusions with confidence. And that's really what internal validity is all about, is how confident can you be that the independent variable is actually the thing that is most likely driving any changes that you see in your dependent variable of interest. So as an example of practice effects, your authors give you the example of, a researcher's comparing two different methods of studying material. And it's a fairly contrived example, but just kind of go with it. Participants use a highlighter while reading, and then they take a test on the material. Versus condition B, participants read a text, make up sample test questions and answers, then take a test on the material. Since it's repeated measures, let's say that all of the participants start by doing condition A. So they start out with highlighter test. Then they do condition B. And they read the text, they come up with questions and answers, then they're tested on the material. The difficulty you would have, because let's say that you find that condition B participants had superior scores in comparison to condition A. So the participants at A, lower scores than when they did condition B. Now you have a problem, right? Logically, maybe condition A was just a warm-up. They got used to the material. Granted, they weren't looking at exactly the same material, but still, maybe they just got used to reading, and through simple practice effects, their performance at condition B was superior to their performance in condition A. So again, if the results indicate that the test scores were higher, let's say they were actually higher in the highlighting condition than in the test development, quiz answer development version of the study, you still have practice effects, but it could be, in this case, because of fatigue. So another issue that we have to deal with, if you had, in condition A, they did better, maybe highlighting is superior. Then again, maybe they just got bored and annoyed. You don't know, because you haven't counterbalanced the order of the conditions. So what this does, what practice effects do, is they create a confounding variable. The passage of time or the repeated exposure to a testing circumstance presents itself as a confounding variable, such that you can't determine the independent effect of your independent variable. The practice effects may in fact explain the poorer performance, but even if we go up here to this bullet point and say, what if, in fact, condition A scores were lower than condition B, you still couldn't conclude that condition B represents a superior studying method, because it could be that the practice they had reading in condition A prepared them to double down and read better in condition B. It may have nothing to do with developing sample test questions and answers. It may just be that they thought, wow, that test was hard, I need to read more carefully for condition B. So it would be a true practice effect. If you have scores higher on A than B, it may be boredom and fatigue, which are also practice type effects or effects of time that could be a confound and interfere with your ability to determine the impact of your independent variables. So what do you have to do in order to protect the internal validity of your study? You have to balance these effects across conditions in these designs so that the effects will average out. And that's my example with the weighted blanket study that my students did last year is a good example of that. So we had two different orders, and we randomly assigned participants to the two different orders, and then we did a test in it before we did our final data analyses to determine if there was an order effect or a practice effect. We in fact found there was none, so we were able then to collapse across those two conditions and look at the impact of the actual application of the weighted blanket. So how is counterbalancing accomplished? As in the example that I've just described, you can counterbalance the order of the conditions. So in the example that I just used with the different study conditions, you could have half of your participants start with condition A followed by B. The remaining conditions start with B followed by A, which is very much like what we did with the weighted blanket study. This will help you to distribute the effects of order across the conditions of your independent variable. Sometimes the practice effects aren't going to be completely eliminated because there's no real way of completely removing practice effects in a repeated measures design. However, balancing them gives you the opportunity to look separately at those practice effects, which is, your authors don't really mention this directly, but what we did in the weighted blanket study was we did a pretest. We really took a look and compared the groups. So for example, one group started with the weighted blanket on, the other group started with the weighted blanket off. We made a comparison, and bear with me, you have to kind of follow this. So we took the group that had the weighted blanket first, the second group had the weighted blanket second. We compared their scores weighted blanket on to determine whether there were between groups differences that were at different times in the experiment. When we detected that there were none, that the difference between the two groups at the two different points in time were non-significant, then we were able to go, okay, practice effects have been controlled for. Not eliminated, but controlled for. And then we could move forward. So this is just a pictorial, a visual way of thinking about how to do these counterbalancing. The only difference between this image and what we did in the weighted blanket study was instead of a post-test, we had a pre-test. So at point one in time, everybody got the same pre-test measures. Then we did either treatment A or treatment B, and then the reversal, treatment B here, treatment A here, and then the experiment was finished. Sometimes what you want to have is a final post-test measure. Sometimes you will insert measurement here, so that you have multiple measurement points. And that's what we did in the weighted blanket study. So we had a measurement here, which was our baseline. We had a measurement intermediate, which was our center point. And then we had, instead of just a final post-test, we had a final measurement period. And we wanted to look for changes across those 3 points in time. Now, how are your authors using complete versus incomplete as a way of describing repeated measures designs? In a complete design, you have practice effects that are balanced for every participant. And that means that every participant is going to get the conditions several times. Now, we did not do that in the weighted blanket study. So our study was, in fact, an incomplete repeated measures design, where we treated the orders as a separate independent variable. And in fact, that would technically be categorized as a mixed design, or as your authors in a later chapter are going to call it, a complex design. In the eventual data analysis, we treated it as a straight repeated measures design. So in the complete design, you have every participant is going to experience the conditions in more than one order. That means that each participant, their performance, when you look at all of their data points, it's a complete experiment. In the complete design, you have the treatments applied enough times that practice effects are essentially balanced at the level of the participant. If you have very simple tasks that don't take a lot of time to administer or for the participant to complete, you can pull this off. If, however, you have tasks that take, let's say, 15-20 minutes for a participant to do, and you have 3 conditions, you're going to be talking about, minimum a couple of hours of participation. And by having that length of participation, you're actually adding another fatigue variable to your set of problems that you might have. So sometimes a complete design is out of the question because it's simply time prohibitive for us. With the incomplete design, each condition is administered to each participant one time. Now, and that's what we did with the weighted blanket study, is we, each participant got each condition once. What you're counterbalancing is the order of them. So some conditions get some orders or some participants get some orders and the other participants get another order. With the complete repeated measures design, one of the classic versions of this is called an ABBA, which is not to be confused with a Swedish pop band. What you're doing is you make, in a complete design, you may create a block where you get condition A followed by condition B, followed by condition B, followed by condition A. And that kind of reversal is in effect counterbalancing exposure to different independent variable conditions. In block randomization, what we're doing is creating blocks which are represented by orders, and then and the orders are randomized. So, if you're talking about ABBA, you might have ABAB, ABBA, and so on. Random generations of the different possible orders, the different permutations. In ABA counterbalancing, you could have a random sequence of conditions, and each time they're followed by the opposite of the sequence. And that's a method of making sure that you're counterbalancing the potential impacts of practice effects. Block randomization is often preferred over straight ABA counterbalancing because practice effects don't necessarily, they're not necessarily linear. So if you're comparing study techniques, for example, or study methods, it may be that the passage of time doesn't have a linear effect. It may be contingent on which they start with, which which type of condition they start with. So if you do just simple ABA, the fact that A was first might be problematic. So with block randomization, you have that added layer of randomizing the order of conditions to deal with that issue, especially when the practice effects are themselves not linear. Block randomization, I looked for images that because I'm a very visual learner, to help you understand how block randomization procedures work. A block refers to all conditions, all possible conditions of an independent variable. So in the graphic that I find here, you have conditions A, B, C, and D that are all the possibles. So in block 1, you have B, A, D, C as your order. In block 2, you have D, C, A, B as your order. Block 3, D, B, C, A as your order. And what you see here is a way of randomizing those orders. Then you have groups of participants that land in each block. And those groups may start with a different treatment within their block. So group 1 starts with B, group 2 starts with A, group 3 starts with D, group 4 starts with C, group 5 starts with D, group 6 starts with C, and so on. So for example, with group 1, they would go B, A, D, C. Group 2 would go A, D, C, B. Group 3 would go D, C, B, A. Group 4 would go C, B, A, D, for example. So I know it's a little confusing. And I remember as an undergraduate having to do one of these with actual subjects, and I had to create a spreadsheet to keep it all straight in my mind. But that's kind of the point. You want to make sure that you have a high degree of randomization. So what you do is generate a random order for the block. Participants complete the order that is at their start point. You get a new random order each time a participant completes the conditions. And that way you are randomizing the practice effects. So you're pretty much spreading out the practice effects across the multiple presentations in the study. This, it does require a lot of organization and planning and a strict adherence to the plan that you set out. But the benefit is that it requires multiple presentations, so you have to have a fairly simple task that can be completed easily, and that you can vary enough so that there's novelty to the task, and then the big payoff is that you are balancing the practice effects, but you do have to be careful in the way that you design it. With ABBA counterbalancing, you can use this when you have conditions that are only presented a few times. You do random sequencing with your different conditions. For example, as we were describing before, DACB is one sequence if you have 4 different conditions, then presenting the opposite. So with ABBA sequencing, it's not just that you only have 2 conditions, you may have 4, but you're saying here's one order, here's the second order. It's the opposite sequence. Now you could then add some complexity. You get a new random sequence, and then you flip it and you do the opposite. So you start with DACB, the opposite is BCAD. Then you get a new random block, say ABCD. Then you reverse it. That's the ABBA reversal. Each condition is vulnerable to the same level of practice effects, but you're spreading them out across different variations of order. Now, a little more about what your authors mean by linear and nonlinear. practice effects. ABBA is only going to be used if you have so-called linear practice effects. And what your authors mean by linear is that all of your participants are going to change in the same way across presentations or across conditions. So let's say it's a fatigue issue. Over time, they're all going to get more tired and their performance is going to go down. Regardless of what condition they start with, fatigue wears them out and their performance gets worse. Or if it's a straight practice effect, that over the course of participation, they get better at the task. And all of them tend to get better at the task, regardless of which condition they start with. Those would be linear practice effects. Nonlinear is, as your authors put it, an aha effect is an example where maybe the task is tricky, but once the participant discovers the way to solve the problem, then they master the task. So if it's a task that, eventually if you find the method that works for achieving the task, once you've hit that plateau, you've learned it, and it doesn't matter what repeated exposures happen. You're always going to be at that ceiling. So once you experience, say, condition B out of A, B, C, and D, perhaps that's the aha moment, and then what you have is a nonlinear practice effect. So you can't use a straight ABBA reversal kind of a technique with a nonlinear practice effect. You would have to use a different form, typically block randomization. So with nonlinear practice effects, you have a built-in confound between simple practice or learning and the independent variable, which would be the distinctive feature making the conditions differ from one another. So when we have nonlinear practice effects to deal with, like the looming, impending, aha, I've learned it experience, then you need the block randomization to tease apart the difference between the conditions, irregardless of the aha moment. Now this is an example from your text where they talked about ABBA counterbalance sequences of trials in an experiment where you have three conditions, and showing, when there's a linear practice effect, and you notice there's a steady increase versus a nonlinear where they start out at 0, but then they plateau and everybody's at the high level. So in contrast to a linear effect where you have a steady increase over time in performance, with a nonlinear effect, once they've completed trial 1, they get the maximum score. So they've learned the skill, and it doesn't matter what condition they're in, they do fine. So you would have to use a different approach to deal with the nonlinear practice effect. So that concludes part 1 of our coverage of repeated measures design. I'll see you again for part 2.